2 and g of x equals the absolute value of x. In part A, I'm going to do f of x in green, all of my g of x marks in blue. So my domain for f of x is everything. My domain for g of x, absolute value graph, and sometimes it's helpful to just draw these pictures out so you have them in your head. You can see from those graphs the domain of g of x is everything as well. Part B. Given h of x is f of x plus g of x, good, they gave us a nice notation. Here is our first important definition. Write an explicit equation. This is an equation with only x on the right-hand side, no function notation. Right now, this equation right here has function notation on the right-hand side. If we want to write an explicit equation for h of x, we're going to write h of x equals, and on the right-hand side, not have any functions. So instead of f of x, we could write x plus 2. Instead of g of x, we could write the absolute value of x. So that is what it means for an explicit equation. And then it says determine the domain and range. Does it make sense that if the domain is everything in the green graph and the domain is everything in the blue graph, and you're adding, this is true for adding, subtracting, and multiplying, that your domain for our function is going to be everything? But to figure out the range, we need to know what the graph looks like. So we want to add this graph plus this graph. So I'm going to draft my x plus 2 graph here. Is that one supposed to be blue? No, that's supposed to be green. Green, no, that green. Okay, there we go. That one's green. And my other one I said was blue, absolute value graph here, right beside it. That one's in blue. And I'll put them together and make a purple graph. So you want to add them. Can you see at 0 on the green graph we have 0, 2. On the blue graph we have 0, 0. If you added those together on my purple graph, I'd have 0, 2. Correct? If I take a point here, -2, 0, and I take that same point at -2 on my blue graph, -2, 2, and I add those points together on my purple graph, I get -2, 2. Are you okay with what I've done so far with adding? Okay, I'm going to add them really quickly right now for you. Just imagine we did a bunch of mental math quickly and figured out all those points. Interesting that it went straight, a flat line to the right, and it has a straight line with a positive slope to the right. Now, when we look at that graph, once you've drawn the graph, can you see that the range is y is bigger than or equal to 2? Was the range easy to see by looking at the equation? No. The range was not easy to see when looking at the equation. Okay? How do we write an equation for this? This purple graph is x plus 2 plus the absolute value of x. Can you see that it sort of made two straight lines in the end? Okay? It made one straight line I could make an equation for, and another straight line I could make the equation. Would you agree that this straight line looks like it's y equals 2, flat line? And would you agree that this straight line looks like slope of 2, because it goes up 2 over 1, y-intercept of 2. Wow, that doesn't look like a plus sign. 2x plus 2. Yes? Okay. With an absolute value graph, you always have things broken into two pieces. In fact, in some of your later classes, they're going to write the equation for h of x. You know how we wrote our explicit equation in one thing? Sometimes they'll write their explicit equation in two different parts. How would they write the two different parts? Well, it's the green graph. The green graph was x plus 2 plus the blue graph, and they say, well, when x is less than 0, would you agree that this part is y equals negative x and this part is y equals x? And so if I do the part when it's less than 0, it's really negative x. And if I do the part where it's bigger than 0, it's really just x. Now check this out. What happens if you simplify the top one? It just becomes 2. Does that match with our graph when x was less than 0? Our graph was just 2. If I make it positive x here, I get 2x plus 2. Does that match with our graph when x is bigger than 0? Yes. So the absolute value, you can often break it up to see algebraically what's happening. And in fact, if I had broken it up and got these equations, I probably could have graphed h of x even faster than just finding a bunch of points individually. So we want to look at stuff individually with certain points to get an idea, but we also want to look at things algebraically to figure out where they're going as well. Okay? Has everybody got this written down? I'm going to erase some stuff for part C. Everybody good? So for part C, I'm going to erase this. And I'm going to erase this. Because in part C, they want p of x to equal f of x times g of x. We want to multiply them together and write an explicit equation for p of x. So the explicit equation for p of x would be f of x is x plus 2, g of x is the absolute value of x. Can you see that if you split this up, when x is less than 0, it'd be an x plus 2 times the negative x. And when x is bigger than 0, it would be x plus 2 times the positive x. So if I simplify that, I'm going to get negative x squared minus 2x. And here I'm going to get positive x squared plus 2x. One where x is less than 0, and one where x is bigger than 0. Those are both parabolas. Both parabolas have x-intercepts at 0 and negative 2. I'm going to graph both of those parabolas. If I have an x-intercept at 0 and negative 2, one parabola is going down. The other parabola is going up. What does my final graph look like? My final graph, if I multiply these two together, and again, you could take specific points. I would hope that you would do 0 times this and get 0. 0 times this and get 0. Take another point, this one and this one. 1 times 1 and get 1. Does that make sense? You could do y values and find a bunch of points. But if I do it algebraically, well, I know that I have this parabola, when it's less than 0, is the parabola that opens down. And then when x gets bigger than 0, I have this parabola, so I have just that one there. And that's my final graph. The algebra lets me find it quicker. Generally, when they put things together, this is a harder question because it uses an absolute value. Often when they put equations together, they take equations you are easier to work with algebraically. Like they might take a parabola times a line, and you get an x cubed graph, which will be easier to work with than this situation. Anyways, questions to practice. 3, 5, and 10.